All right. Oof. Check, check. All right. Gotta get rid of that. Cool. I think we're good to go, dude. Let's do some math, man. We're on number 23. And this stuff's pretty chill. This is a strange question. I don't think it'll be on the test, right? All right. Let's see what we got here. Oh, I have this thing locked to the wrong screen. Give me just a second. All right. There we go. So we just need to like multiply it all by multiply the right side by cosine over cosine and multiply the left side by sine over sine. And then start factoring shit. Let's see if that works. So got sine. Whoa, what the? I don't think I pressed that button. I have way too many things on my desk right now. And this desk is too small. Like... Oh, I keep clicking buttons on this thing. Okay. Did I just freeze? What is this? Don't need that. I'm gonna try and combine these two. There we go. Okay. I'm just gonna start fresh. The denominator should be just like sine theta, cos theta, right? Some fun tricks. You can press shift and then like the arrow keys to highlight stuff. It's like a fun way of not having to like hover over and click stuff because that annoys me. The other one is you can put backslash and then type theta. You'll get theta. Same with pi, same with square root. Like I hate clicking down here, it doesn't feel good. Anyway. So I added sine to this, so this is gonna be sine squared now, I'm pretty sure. What the hell? Why would I put it there? I think this makes this cosine squared theta. Do I need to add it to both sides? I guess I do, right? No, I don't think so. I have no idea, if we're being honest. Let me think. Oh yeah, I think I do. I think what it wants you to do is like factor. Does factor even work that way? I don't think it does. I don't think I need to do that. It's just, I have no idea. Whatever. This is gonna like fuck me up. I'm pretty sure I multiply both sides, like all of the nomials or whatever in there. This is something I need to brush up on, is like the subtracting and adding on the top of a... So I'm pretty sure now I can just do this and get rid of this part. I'm not entirely sure though, right? It's like there's no way to know. So I think this makes us 2. Or no, it just gets rid of it, right? Because I'm minusing it and I'm adding it. Subtracting it and adding it. So it's just gone now. There's just plus here, which equals 1. See, I don't know if this is a multi-step problem. That's the only issue. All right, I guess that's the answer. Is that the most simplified version? I guess it is, right? Type your answer in terms of sine and cosine. Okay, that's all right, I somehow did that right. That's great. I'm smarter than I think I am, for once in my life. Multiply and simplify. Okay, first thing is just like the FOIL thing, sine squared plus sine cos. I gotta have to remember it. I think it's gonna be like 2. Because I'm doing it twice, right? Plus cosine squared? That should be it, right? Sine squared, cosine, sine, cosine squared theta, and then sine cosine plus yeah. -1. And all that over sine theta. Cosine theta. I think I gotta put one more here too. Multiply and simplify. Cosine squared theta -1. Is that a thing? Is that a Pythagorean identity? Because I think this just equals sine squared theta again. So this is 2 of those. And get rid of that. And then is that the most simple version? I think I can like, hold on, I'm gonna do it the other way. Oh no. Yeah. All right. So this is just, okay, we're good. So I think the final answer is I gotta separate these two. And I just divided one of them out, right? Isn't this the simplest answer? Can I divide out one sign here? Is that how that works? I can't, right? Can I? Let's try it. Which this is just tangent, right? Can I just make this 2 tangent? Let's see what I'm doing wrong here. Why would it be in parentheses? Oh, two. Okay. Oh, I see. One's one here. Okay. Dude, this music is... What is this? Garbage, dude. Sorry. Music is just like way too... Like... I don't know, man. Lo-fi has changed a lot. It used to be a little jazzier. The whitewashing has been complete, dude. Can it just be this now? Is that it? No, just divide one out. Cancel the common factor. What's the result? Is it... What the fuck, dude? I divide one out. And I just get one left, right? Two. Oh, okay. Whatever. That'd be if it was squared. Fuck, I'm so bad at algebra. It sucks. Okay, we got 1 minus cos squared theta. Can you imagine taking a test in this software? Like, bro. It's like everything on here, doing anything on here is so painful. All this over. Okay, so this becomes 1 now. And then 1 minus 1 equals this now. And then the answer is 2. How's it different? I had to change up the music, man. It's just like, I feel like it's mocking me. Don't know how to explain it. No, it's like, whatever. It's -2? I'm gonna come back to that. The multi-step problems are so annoying, dude. Yeah, that's pretty easy. So one, rewrite the left side of the expression by distributing. I have to do that? I feel like it's not that it's not that hard, right? Like, just use the Pythagorean identity and then multiply it, right? Like, why make it more difficult than it has to be? Right, the second term expression from the previous step in terms of sine and cosines. Okay. So here's an example of how you can solve it if you just make it way harder than it has to be. And Pythagorean identity. Let's use that last instead of first. It's minus. Right? It's just difference of squares. Right, the numerator is expressed from the previous step in terms of cosine. Mm. Right? All right, this is this part here is just turned into 1. So it's 2, let's see, this one. Yeah? Okay, I guess I can get rid of these ones. Oh my god. I guess it's 2 minus. I guess so, dude. Interesting. I need more practice with this stuff. It's not good. I cancel the like terms. Exact value. So this is sum and difference formulas. I mean, And it's just pi over 12, right? No. No. 15 degrees is pi over 12. Okay, this is sum of difference formula. Okay, the formula for this. I don't know what's happening with that. So we're doing 60 minus 45. Which is it's so this is square root of 6 over 4. This is square root of 2 over 4. Add them together. That's square root of 2 plus square root of 6 over 4. Easy. That's just pi over 2 minus pi over 6. No. So that's 75 degrees. It's just like 90 degrees minus 15 degrees, right? So yeah, this is yeah. This is sum of sines. So we're doing which is sine of 30. Okay, so we want all the things of 45 degrees or square root of 2 over 2. Cosine of 30 is square root of 3 over 2. So I'm pretty sure it's the exact same answer we just got. This is square root of 2 over 4. Square root of 6 over 4. And add them together. Same answer. Is that even possible? I guess it makes sense, yeah, because whatever. That's a lot of fun. Yeah. Fuck. I didn't solve that one yet, did I? Whatever. I'm still coming back to it. Dude, we're making progress though, man. I gotta stop stressing. This is just tan 30, right? Oh. It's square root of 3 over 3. Right? I mean, is it not? Okay. Why they gotta make it so stressful? Oh god. It's this one. This one's a fucking monster. I'm doing this one on paper. Alright, it's in quadrant 4. No. Okay. There's just like too much stuff colliding with me right now. Okay. So angle A is in quadrant 1. Cosine is x. Over r. So this is 2. This is a square root of 85. So I just had to find Pythagorean theorem to get y. This is 7. This is 25. This is looks like a Pythagorean triple here. Maybe not though. So I gotta do 85 minus 4 equals square root of 81 is 9, so y equals 9. Right. But it's negative, right? No. Yeah, it's negative. Negative 9. So for B, sine of B is negative 9 times the square over 85, right? Is that correct? Yeah. Cosine B We already know that. That's 2 times the square root of 85 over 85. Tangent B is Is that right? That makes sense, right? I don't know, man. We'll worry about that when we get to it. A is... What is 25 times 25? I can't believe I haven't busted out the calculator yet. That's pretty good. So we got 625 minus 49 576. That looks pretty even. $24. So A equals 24. Or X equals 24. So sine A is just 7. Sine B, 24. I mean, cosine B. And then tangent B, A is aha. Is just 25, right? No. Okay. Be 7 over 24. And then tangent B is looks like -9 times square root of 85 over 2 the square root of 85 which is -9 times 85 over 2 times does that work? Okay, -9 over 2. They just cancel each other out. Okay, that makes sense. Cool. So -9 over 2. We're almost there. We're getting there. So now we have all this bullshit that we need. Now we can start writing formulas. Okay. So we got 7/25 times 2 times the square root of 85 over 85 plus 24/25. Yeah, times -9 square root of 85. Fun. The next formula. Sum of cosines. So cos u times cos v minus sine u times sine v. What the? I don't know why I was being Chrome audio captured. That was terrifying. Whatever. Okay, 24/25 times 2 over the square root of 85. Minus it doesn't matter what order these are in, just gotta put both. All right, C. It's this same thing, right? But with just a minus sign. Yeah? Yeah. And then 10 difference. I don't know. This is minus on the top, plus on the bottom, right? So first tangent. Minus on the top, plus on the bottom. I said that. Okay. First tangent is 7/24. And that reduces. So I can remember that. Right? It's like. No, it doesn't. Okay, whatever. Minus. -9/2. And then 1 plus all right. Now we're almost halfway through this problem. Now we can start doing the problem. So that's fun. Now that we've written out equations for 20 minutes, we can start doing the problem. There's just not enough room for this tablet. Remember it. No more drawing pad. Wow, that already feels 10 times better. Okay. So we got 725. Okay, there's our denominator. Can I just make this 14? Yeah. It should be the same, right? There's gonna be some stupid ass like I hate Pearson so much, dude. Can you just give me a normal number? Okay. This is what I got. This really nice looking answer here. This is the same as -212. Does not appear to be. Oh, 202. There we go. And is 202 going to... It does. Does not. All right, I believe we have the answer. This is a score 85. Let's see if that's right. I bet you it's not. Doesn't feel right. Oh yeah, it's so much like such a... That's way better than like a rounded decimal. I love looking at this. Beautiful. What a great number. Okay. Jesus Christ. I just don't see how this is useful to anybody, right? It's like I see that we get an exact answer here, but it's like, I guess maybe it's easier to put in a calculator because you don't have to have a decimal or like rounded, or but isn't it just easier to put this cosine a plus b into a calculator, right? Like every calculator has it. Maybe, I guess not. Whatever. I need to just accept that this is the way it is. This is my life now. Okay, we'll save this for when we're solving the other one. Dude, I just can't imagine like doing the same problem when I on a like TIE4. Like it stressed me out so much. Okay, this is like 48. I'm gonna type the whole thing first. Okay, 24, 25. Okay. So this should be the same as like 48 times the square root of 85 over 2125. Oops. And 36 times the square root of 85 over. What did I do wrong? 7 times 9, not 36. It's not. 63. I'm dyslexic. Okay. So I gotta do 48 minus 63. Or 48 plus 63. 111. So it should just be 111. Okay. Simplified. Gorgeous. Dude, if I get this entire thing problem on the first try, I'm gonna cry. It's like these. It's like the whole thing is easy until they start adding these fucked up numbers in here. But I guess it's good practicing with fucked up numbers, you know? Because the real world is made of fucked up numbers. Not everything's gonna be perfect, right? So I'm just doing the same thing with minus, right? So this should just be like 14 plus 216. So I can make this 230. Yeah. Okay. $46 over 2. I think I checked. So is that the same though? I'll be right back. Anyway, it should be the easy one, right? Like I'll have to do, let's turn the top into Oh man. The top turns into like 14 or 48 minus it's -9 times 24. I'm just gonna, I can get rid of all of this now. $216. So it's plus 216. So it's like, should be like 230. So yeah, 7 or 24. I can just see this. 115 over 24. So on top I got on the bottom. So 1 minus plus minus 21 over 16, which is like 5/16. I think this is the same as like 115 over 24 times -16 over 5. We're gonna see if that's correct. That makes the denominator 120. Negative 840. Which is -46 over 3. So I should get the same thing from, if I do like 1, 5 over 24 over 16. It's -5 over 16. Okay, and so now I'm just gonna put the whole problem in, just to make sure. All right. I think I found the answer. Dude, if I get it all on the first try, I'm gonna cry. Oh my god. It happened, dude. Holy shit. I'll save this moment. Nice, that's worth 4 points. Nice is worth 8 points out of 206. It only took me 30 minutes, you know. I'm sure there's a fast way to do it. There's got to be, right? Holy balls. Okay, so we're past the summon difference formulas, which is a beautiful thing. Good God. Okay, so onto this thing. And this thing is really easy. And it's funny because I just did exactly this, but like for a much more difficult problem. Okay, so we have the angle over here. If you just orient it that way, it's way easier, right? 16 is the x-axis. 32 is 90 degrees. So X, Y, R. Sides, angles. Don't need the, I don't know if I even need the angles, but we know this is 90 degrees. So 32 squared minus 16 squared equals y. Oh, so nice to get rid of that. Square root of 768. Let's just double check though. Excuse me. All right. So we have our answer. Square root of 768. So sine, cosine, tangent, cotangent, secant, cosecant. So x. Yeah, square root of 768 over 32. There must be a way to simplify that. Is that the same as like 16? Whatever. Whatever. Like, okay, so let's say like square root of 192 over 16. What did I just do? So I put 2 on the top. So if I make this 48, make this 16. Holy shit. We should make this square root of 48 over 4. Nope. Square root of 48 over 8. Yeah. So it's gonna be simplified further. Square root of 12 over 4. Great. Square root of 3 over 2. I guess because it's whatever. Maybe there's a way to like prove this. It's interesting. Okay, so yeah, I guess that works, right? If cosine's 1/2, then all the proportions are the same. Right? Like they sort of have to be, don't they? Interesting problem. This is square root of 3. Okay. Learned something new today. That's a interesting, fun problem. Oh man, we're back to this. This is like a simple one though. That's why I spaced it out. It says do not use a calculator. All right, I'm gonna just try and work it out because this is not helping me. Tangent 41. Okay, I see what this identity is. It's essentially like tan 90 minus 41 is equal to 1 over tan 49. And also this is equal to tan 49, right? Yeah. Okay. That's what the deal is. So this is just 0. So sine 54 should be equal to cotangent 36. Which is like 1 over tangent 36. Nope. I got that the other way around. Nope. Okay, so it's right? Nope. How about this? Okay. So be cosine. Okay, figured that out. So we have cosine 54 over sine 54. So what we have here is cosine 54 minus cosine 36 minus sine 36, which is 0. How did I mess this up? Is it because it's rounding before it's doing the subtraction? Whatever, we know it's a 0. Okay, I just broke the calculator. Solving the triangle. B. This is will be. So need sine is opposite of hypotenuse. Sine of 40 degrees is equal to x over 8. So that's 8 sine 40 degrees is equal to opposite. So is y, right? Actually B. B. And then cosine is adjacent over hypotenuse. So 8 cosine 40 is A. All right, let's do it. Should be 5.14. Huh? Oh, I did the wrong one first. $6.12. Dude, 6.13. Right? And this is 5.14. Angle A. 50 degrees. Yeah. All right, we're getting to the like one part where they're putting in word games. Here's the camera. Here's 11 feet. But really it's 6 feet. That's a distraction. So we're just gonna redraw the triangle. Y is 6 feet. X is 18 feet. 18 squared times 6 squared. So hypotenuse is 108. This adjacent over opposite. Adjacent over opposite. Opposite over adjacent. All right, so it's tangent opposite over adjacent, right? But it's the inverse, right? Yeah. $71.6. Right? Fuck. We'd try 180 minus or 90 minus this. 18.43. Okay. $769. Oh my god. There's the obelisk. There's a shadow. This is how high the sun is from the ground. It should be this angle, right? 33.6. So it would be opposite over adjacent. Seven, 6, 9, 10. 33.6. 510.92. That makes sense because the lower the sun is, the longer the shadow, right? Is that rounded correctly? 2 decimal places. Okay. All right, law signs. Love doing this one. Okay. So we know angle A. Angle B. Don't know any of that. We know the length of B is 5. So we got sine 35 is equal to sine 40 over A. So this is 5 sine 40 divided by sine 35 is equal to A. All right. Two decimal places, 5.6 should be the length of A. How are we solving for C again? Oh yeah, we do 180 minus 40 minus 35. 105 degrees is C angle. So that gives us like sine 35 over 5 is equal to sine C over what we 105? Oh no, sine 105 over C. Good. Good. All right. So you can see by itself. I'm like gotta move it over here. Right? That's the same thing I did for this, right? I just put in the different values for C. Please? It looks like it's the long side though. So I don't know if I did this right. Oh no. I replaced the wrong angle. There we go, that's more like it. This should work. All right, dude, we did it. Feels good. All right, man. 4 more questions, dude. We're tearing through this thing. Two sides of the angle given below. Determine whether the given information is one. It's probably 2, right? It's always 2, isn't it? Cause like, all right, this one takes forever. So I'm gonna do it slow, so I only have to do it once. I'm gonna do it assuming there's two triangles. Okay, we know A length is 6, B length is 10. A angle length is 50. All right, so we do sine 50 over 6, and that's what we use to modify everything, right? So just gotta make everything equal to that, right? So for this equation for B, to find the first angle, we're doing sine 50 over 6 is equal to sine B over 10. So we're gonna times 10 over 1. And then we're gonna put that in an inverse sine. So that gives us sine inverse 10 sine 50 over 6, I think. Gotta find the inverse. Almost messed it up already, dude. I just got started. That doesn't look right. I'm trying to find an angle B. Oh, I didn't put the exponent. Ooh. No triangles produced? All right. It was undefined, so no triangle. So I draw that out for nothing. Great. I'm just going to reuse it right here. I'm going to reuse it for this problem. And just change the angles. Unless this is... Oh, okay, cool. To avoid confusion, I'm just going to draw it all again. I thought about just like writing over what I had, but... Like, I know that's just gonna throw me off. So we got our thing here is sine 30 over 4. And use this to find everything else. It's like our given, right? So first thing is find the angle for A, right? So it's basically the same formula we just did, right? We put the 6 here, we put it in the inverse sine. I'm kind of skipping through it, but essentially that's what we got. So change this to 6, this to 4, this to 30. All right, we got a freaking angle, dude. What am I rounding to? 2 decimal places. So 48.59. For our first triangle. Okay. So now we can do 180 minus 48.59 minus 30. Now I'm still like not 100% sure on how to do this part, but do the first triangle where it gives us 101.41 as our third side. Our third angle. So now to find angle B, we're doing sine 101.41 over x is equal to, or this is B, you know, it doesn't really matter. This thing right here, convenient. So we got to put 4 over here, sine the numerator, denominator. So that would give us 4 sine 101.41 over sine 30. Should give us B. Because yeah, we just moved that to the other side as like right side up. And that gives us the length 7.84, which you can, a good hint that we did it right is that it is longest side, longest angle, you know, so good stuff. Now let's see if there's a second triangle. There probably definitely is. And we do like 180 minus 180 minus 48.59 minus 30, which will give us our other option for A or C. I can't remember which one. I think like this is our other option for C. The way to test it is we just do another like difference of signs thing, right? To find out which one this belongs to. Assuming it's C, right? Or A, right? We take this, right? We compare it to this number here, the angle 131. It should give us 6, but we don't know that. So we're putting A. We're not sure if it's 6. We want it to be 6. So this ends up turning into 4 over sine 30. This thing, and then putting A over the side. Yeah. So it's like 4 sine 131.41 over sine 30. That should give us 6. It gives us about 6. So that'll work. That's fine. It's because it's rounded, right? So that should be the other option for A. 131.41. And that leaves us with 18.59 as the other B. This one won't have the same length because this length has to change to make the second triangle. And that's how we know. So to find B, we just got to do basically the same thing, right? But we're just going to replace this digit with this angle, right? So we got $2.55. Now, let's try it. Smaller angle A. Capital is the angle. So, got 18.59. B. Wait. I almost fucked it up. Smaller angle A is 48.59. And that triangle B is 101.41. And the length we found was 7.84. A is the angle where the length did not change. So that's 131. B is the angle where the length did change. That's 18.59. And its length is now 2.55. Please be right. One time. Holy shit, we got it. Oh. Dude, I practiced this for so long yesterday, dude. Jesus. I almost died. I did this math shit for 4 hours yesterday. And 2 of those 4 hours was spent on one of these problems. One of those problems just like that. It was just like such a headache, man. Like trying to understand where all that goes. Just something about the second triangle, man, like really fucks me up. Okay. This is law of cosines. We know that because we don't have any angles that match with their corresponding side. And the law of cosines is way more chill and cool. Yeah, law of cosines is chill as fuck, dude. It's like it's not on that page. I have it in my head, sorta, but I don't need to memorize it for this test, right? So why not just check, you know? Law of cosines. First thing we're finding is a side. which we use c squared equals a squared plus b squared minus 2ab cosine c. Beautiful. What an easy to remember and simple formula. In this scenario, our cosine c is 95. Side A is 3. Side B is 5. We have 2 here as well. And then 3 squared plus 5 squared. And that equals this, which is what we're trying to find the side C, the squared version. So we got 3 squared plus 5 squared plus 2, 3, 5 times cosine 95. And then I need the squared version of that. 6.05 should be the answer. Nice. Good stuff. So now we're finding angle A, which will be angle A is equal to b squared, the side, minus c squared. It will be, sorry, plus c squared minus side A squared over 2 times b times c. Whatever you're trying to find for goes here. The other 2 sides go here. Easy. So got and this is cosine. Yeah, okay. So at the end we're gonna do an inverse cosine of whatever we get, right? Pretty sure. Oh well. A is 3. Okay. So we got 5 times 6.05. Gotta square both the. No, this is plus. And this is a 5, right? This is B? Yeah, 5. Okay. Grab the whole thing. Over 2 times 3. No, times 5. 5 times 6.05. Take this and put it into the inverse cosine, right? $29.6. What's the rounding? 20.6. Yeah. Yeah. Beautiful. Now I just gotta do the same thing for B, which is very easy. Just switch some values out, right? B was 5, so we just gotta turn every 5 into a 3. And vice versa. $55.4. It's gotta be it, right? Wow, dude. The final stretch. It's amazing. Solve the triangle. Okay, same thing, man. But it's now way easier. Because all you gotta do is use this one formula for finding angles. And then just keep rotating these ones in and out. God, I love the law of cosines. It's so chill. First one we're finding is A, so I gotta put that one as 18. 14 is A. And this is 18 and 15. So freaking easy, dude. 49.02. Easy. Second one's probably B, right? Okay, B is 15, so we're switching 15s and 14s. $54.17. Oh, I gotta round it. I didn't round it. Good job. All right. And then just switching 15s for 18s. Send it. 76.6. Beautiful. Oh, man. It feels good. One more question, dude. 94. This one is worth more than... Oh, wait. This one I still haven't finished. 2 more questions. Okay, whatever. Oh, I'm getting excited, man. It's been such a grind. I was like so stressed out at the beginning. All right. Clint is building a wooden swing set for his children. Okay, cool. Don't even know. Each supporting end of the swing set is to be an A-frame. Sounds like a triangle. Each end. 2 7-foot-long 4x4s. Joined at a 45-degree angle. So this is 45 degrees. And these are each 7 feet. To run the things up to switch a frame to concrete footings. Okay, so we just need to find this, right? Right? How hard could it be? Oh, this is the one where you divide this in half, right? No. We're just gonna start plugging shit in, dude. See what happens. Using the first law of sines for this. About 5.36 feet apart. Does that work? Oh, it works. So what I did is just put it in the first law of sines of cosines and used 45 degrees for the angle to find the length. All right. I thought that was going to be more difficult. So this one has been pissing me off. Maybe it'll be easier now since my brain is fully awake. So we got sine times cosine over 1 minus sine squared theta. I'm already simplifying it. Plus cosine squared theta. Plus 2 sine theta cosine theta. Okay. I think that's there's 1/2, right? Because it's like, you take this, it's Pythagorean theorem, Pythagorean identity, which just makes it 1, right? So we got 1 minus 1 plus 2 sine theta cosine theta. Right? Then you use this, eliminate that. This cancels that. So now you just got 2. But you still have to have a 1 up here. So I think it's just 1/2. Is that the identity? Did I get it right? Sine squared plus cosine squared equals 1, right? So is it 1 minus 1 equals 0? Or is it negative? Just because, like, I have to do everything else within parentheses. So let's try negative for fun. Yeah, because I think I have to subtract this at the end. I don't know, man. Sure. Dude, I really don't know. I don't know why it works that way. It works that way. All right, that's the end, man. We fucking did it. 2 hours, 36 minutes, 49 seconds to do half of this test, half of this review, but it's done. And feels good. Hopefully, you know, 6.5 hours of studying on this review will be enough to pass the test. That plus all the time I spent on the homework and you know, various other watchings of YouTube and pondering Ulm and traffic and all of that, right? But either way, man, it's satisfying. If you want to see the first half of this where I crash out, it's like on here. It's this one. Pretty sure I did not even get to the... Yeah, this is all on that fucking law of sines problem. This whole 51 minutes. When did I finally give up? What is this quality? Okay. That shit looks so funny with the glasses. All right. What am I doing here? 2 sides. I already know 2 sides. Only one triangle finishes. Let's try that. That sounds like a theory. Is that... No, I'm still fucking on it, dude. Still fucking it up. I see. Okay. I like missed one number. No way I tried it again. Good lord. Right, it was like how you move sine across an equation. There's no way. Still? So that's like pretty easy, right? Okay, this is starting the review right here. An hour and 51 minutes in. Okay, there you go, dude. So if you want to see yesterday's homework, it's the second half of this video. If you want to see the first half of the review, which is, I would say, I don't know. There's a lot of easy questions on this. I think I did like the most difficult ones like halfway through today, right? So it's like in this video here that we're doing, it's like most of the, I think the most difficult thing is the I think it was this one. No, this one. This one just takes so long to do. So yeah, I spent like 30 minutes on that one. I think from like hour 1 to hour 30. But yeah, man. Beyond that, I'm gonna go to sleep so I can wake up on time. But if you're still out here studying, I wish you luck. Yeah. If you have any questions, now's the time. Because I'm going to bed. And yeah, that's all I got. Do I have any questions about myself, about this? No? At this point, I feel like all you can really do, right, is just start slamming shit together until it works. And then it's hopefully you can, I don't know, last question, the last test is like 20 questions, right? It's like, it felt like enough time. I had time to like go back through the test and like look over the questions again to make sure I got the numbers right. And I got to fix a few of the mistakes that I made. But by the time I was finished, everyone had already left. But I'm just saying, dude, like, I'm gonna take the full 2 hours. If there's anything I can fix, right? Anything I can double check, dude, I'm gonna go back and do it, man. Like, why not? Why wouldn't you, right? Either way, yeah. I'll gladly be in there the whole 2 hours. To this freaking question, man. I know this isn't gonna be on the test tomorrow, right? Or like anything new is complex, which is nice. I feel like that's a nice setup the way he does it, right? It's like the Pearson homework is like really fucking exhausting, but if you do it, then it's like the test makes the test really easy, you know? Alrighty. So yeah, I think that's the end, man. Yeah. Alrighty. I'm going to sleep, but I hope these videos are helpful to you. You know, because it was a lot setting it up, you know, just like putting all the cameras in the right place, and I built this thing, you know, to like enable like the, yeah, like it builds like a wooden frame with a light, you know. And honestly, all of this is for my own sake because I feel like I study better when I feel like I'm being watched, you know. And then also I like the feeling of being under the pressure like a test would be, you know. And that's like really silly, but it's just so easy for me to slack off if I'm left to my own devices, you know. Anyway, good luck. You got this. See you tomorrow.